In the shadowed skies of the 21st century, there glides a machine that forces even the most modern radar systems to bow in helpless surrender. This is no ordinary aircraft. This is the B-2 Spirit, often called the silent ghost of the sky, a profound symbol of absolute power and the global strategic deterrence of the US Air Force. When the B-2 silently slices through the air at an altitude of over 15,000 meters, its presence goes unnoticed. No air defense system dares to claim it can catch its reflected signal. This chilling invisibility represents the greatest fear for any nation, a destructive storm capable of striking at any moment, from anywhere, without any prior warning. What does it mean to wield such a silent, decisive force in the modern world? Born as the ultimate strategic card, the B-2 Spirit is far more than just a machine of superior technology. It serves as Washington's sharpest political deterrent. Moreover, the B-2 is not a weapon that can be mass-produced. Only 21 were ever built, each costing up to an astounding $2 billion USD, making it the most expensive military equipment ever created. This is a weapon that only the world's #1 power dares to own and operate, a stark symbol of unchallenged national power and strategic superiority. The story of the B-2 Spirit is not just about an aircraft. It embodies the American style of global deterrence, where technological might, strategic foresight, and political messaging blend seamlessly into one. Where will it appear next in the sky? Who will be the next target of this silent ghost? In the tense darkness of the Cold War, as the US and the Soviet Union ceaselessly confronted each other on multiple fronts, the US military faced a critical paradox. They needed to deliver devastating payloads, even nuclear bombs, deep into enemy territory. But this was only possible if their bombers could successfully penetrate the Soviet Union's increasingly dense and sophisticated air defense systems. Systems like the S-300, MiG-25 and MiG-31 had transformed the Soviet sky into a deadly, impenetrable zone for conventional bombers. Giants like the B-52 became easy radar targets, while even the B-1A, despite its speed and power, was still readily detectable. So the urgent question arose: how could an aircraft approach a target without detection, deliver its payload, and then vanish without a trace? The answer began with groundbreaking pilot projects such as Senior Blue and Tacit Blue, small test models with unconventional shapes whose sole purpose was to disappear from the eyes of enemy radar. By the end of the 1970s, these revolutionary principles were distilled into the Advanced Technology Bomber ATB project. This was a high-stakes, multi-billion-dollar endeavor that directly paved the way for the birth of the mighty B-2 Spirit stealth bomber. Through pioneering theoretical research from individuals like Dennis Overholzer and others, Northrop chose a radical flying wing design, integrating the fuselage and wing into a single, seamless structure. This was not merely for aesthetics, but to profoundly optimize both aerodynamics and stealth. Every line, every curve on this aircraft was meticulously angled to scatter radar waves in all directions, preventing them from returning to the enemy's receiving antenna. This was no random occurrence. Each contour of the B-2 was precisely determined by hundreds of hours of calculations from the Cray 2 and Cray XMP supercomputers of the 1980s, at a time when computer power was still limited. The goal was to create the most difficult shape to detect by radar in the X and S bands. The outer surfaces were meticulously coated with radar-absorbent material, or RAM, designed to absorb radar energy rather than reflect it. The engine air intakes were ingeniously hidden on the back of the wing, shielded by sawtooth radar wave-scattering plates. Even the hot air emitted from the engines was thinned and cooled through narrow gaps at the rear of the wing, minimizing infrared traces, which are critical for evading heat-seeking missiles. This combination of design features made the B-2 stand out, appearing on a radar screen not as a recognizable aircraft, but merely as a fleeting, barely perceptible blip, if at all. In 1981, escalating geopolitical tensions and pressing strategic requirements led the US Air Force to sign a development contract with Northrop. What initial challenges did this ambitious project face? Initially, the plan called for 132 aircraft, but right from the start, the journey was fraught with difficulties. The design wasn't perfect, and the development of cutting-edge stealth technology demanded a level of precision that was still largely in the testing phase, leading to significant cost overruns and delays. A 1989 Government Accountability Office (GAO) report revealed that costs had soared to $12 billion USD, and the schedule was pushed back 3 years, primarily due to ongoing design corrections and restructuring efforts. Ultimately, the final production number was drastically reduced to just 21 aircraft, a consequence of the post-Cold War détente and limited military funding. Yet despite these setbacks, the B-2 emerged as a singular, monolithic shape, embodying stealth and pressure. It became the definitive symbol of American strategic tactic. The B-2 Spirit, the ultimate symbol of stealth bombing power in the 21st century, stands as one of the most complex and expensive military machines in the history of world aviation. A closer look at its detailed specifications reveals precisely why the US Air Force consistently regards the B-2 as an irreplaceable asset in global strategic deterrence campaigns. First and foremost, it possesses a huge physical size, yet it is engineered with extreme sophistication. Its wingspan stretches an impressive 52 meters, equivalent to the length of a mini football field, while its fuselage is a mere 21 meters long and approximately 5 meters high. This wingspan is truly remarkable even for heavy transport aircraft like the C-130 or C-17. But how does such a large aircraft achieve its legendary invisibility? Unlike any bomber that has appeared in history, the B-2 has an appearance that is almost alien, like a strange spaceship emerging from a science fiction novel. Its unique flying wing design means the entire fuselage and wing are one seamless piece, completely eliminating any vertical or horizontal tail. This radical design has done away with almost all traditional radar reflective surfaces. There are no exposed landing gear or ostentatious air intakes like those found on the B-52 or B-1. Instead, the B-2 is composed solely of smooth curves precisely tilted at every angle so that enemy radar waves are scattered in all directions, except back towards the receiving antenna. This is not arbitrary. Every line on the B-2 was determined by hundreds of hours of calculations from the Cray 2 and Cray XMP supercomputers of the 1980s. Even with the limited computer power of that era, these calculations created the most difficult shape to detect across various radar bands, particularly the X and S bands. The air intake for its General Electric F118-GE-100 engines is cleverly hidden on the back of the wing, shielded by a sawtooth radar wave scattering plate. The hot air emitted from the engine is also thinned and cooled through a narrow gap on the back of the wing, minimizing infrared traces, crucial for evading heat-seeking missiles. This meticulous design means the B-2 does not need to fly low to avoid ground radar, unlike the B-1 Lancer. It can glide freely at an altitude of over 15,000 meters, where the atmosphere is thin, saving fuel and extending its journey. This opens up a completely new attack strategy, a surprise strike deep inside enemy territory, dropping JDAMs or B-61/B-83 nuclear bombs right in the middle of a command center without any radar detection, and then departing in silence. Even if enemy radar were to detect a strange object, the B-2 would be hundreds of kilometers away, having already completed its primary mission. What challenges does this radical design pose for flight stability? The paint on the B-2 Spirit is not simply a coating that protects the surface from corrosion or environmental impacts like conventional aircraft. This is one of the core elements that makes up the famous stealth ability of this Sky Ghost. The surface of the B-2 is covered with a special radar wave-absorbing paint called RAM, radar absorbent material, a material with a molecular structure specifically designed to trap and eliminate radar wave energy when colliding with the aircraft. When enemy radar scans, instead of reflecting the signal back to help determine the target's location, most of this wave energy is absorbed or scattered. The back radiation becomes so faint that the B-2 appears extremely dim or even invisible on the control screen. What's even more special is that this RAM paint layer is not applied just once. After each long flight or extended mission, technicians at Whiteman Air Force Base must meticulously check every square centimeter of the surface to ensure that the material layer is not cracked or peeled off. Even a tiny scratch can cause radar waves to reflect back more strongly, potentially revealing the aircraft's position. This rigorous maintenance work contributes significantly to the B-2's extremely high operating cost, but it is absolutely critical for maintaining the perfect stealth capability of this crucial weapon when penetrating deep into enemy airspace. In addition, the B-2's surface is designed to optimize aerodynamics with beveled edges, completely avoiding right angles or concave and convex details, as these are areas where radar waves are most easily reflected. All details, from the landing gear cover and wing edges to the engine air intakes, are designed to be completely closed and seamless, avoiding the creation of any radar reflection points. Combined with the RAM paint layer, this helps the B-2's radar cross-section to be equivalent to that of a small bird. This makes it incredibly difficult for even the most advanced long-range radar systems of Russia or China to detect when the B-2 is flying in high stealth mode. But stealth isn't just about radar. Not only does it absorb radar waves, but the B-2's paint and shell material also have the ability to reduce infrared radiation levels, another vital factor in the fight against heat-seeking missiles. Thanks to this special insulation layer, the hot air from the engine, when escaping from the exhaust port, is significantly cooled, reducing the risk of being locked onto the target by the enemy's infrared sensors. The combination of this unique aerodynamic design, the RAM material, and this special paint layer has transformed the B-2 into a true ghost that silently sneaks deep into enemy territory. Almost no one can recognize its presence. This is what has helped the B-2 Spirit become a strategic obsession in every sky it flies through. The technology used to create the RAM radar-absorbing paint layer on the B-2 Spirit is one of the most closely guarded military secrets of the US Air Force because it plays a key role in maintaining the superior stealth capabilities of this aircraft. In essence, this material layer is a complex mixture of special polymers with randomly arranged or crystalline structured conductive metal or ceramic microparticles. When a radar wave is emitted, the electromagnetic energy is spread and absorbed into the material instead of bouncing back to the enemy radar. The production process of the RAM layer requires very high purity and precision. The nanomaterial particles in the paint must be uniform in size and precisely distributed to create the maximum electromagnetic absorption effect at the specific military radar frequency bands. At the same time, the paint material must also withstand significant thermal expansion when the aircraft flies at high speed and the low pressure of the stratosphere without cracking. Even a tiny crack can destroy the stealth ability of the B-2. To achieve radar wave absorption across many different frequencies, from the X-band of fire control radar to the L-band of early warning radar, this RAM layer must be manufactured according to a multi-layer model. Each layer of material inside absorbs a certain frequency band. This technique is akin to growing a multi-layered coat, with each layer capturing a different type of electromagnetic signal to completely eliminate the reflected waves back to the enemy radar. This technology is extremely complex, and so far, only the US has completely mastered it. Other countries, such as Russia or China, are still trying to develop RAM layers of similar quality for aircraft like the Su-57 or J-20, but have not yet reached the level of sophistication seen in the B-2. Because of this complex and sensitive nature, the work of painting and maintaining the RAM layer cannot be carried out anywhere but only at special facilities with extremely strict procedures. Every time the aircraft completes its mission, the RAM layer is checked by laser to detect thin spots, peeling, or damage due to rain and dust collisions. Then a team of technicians meticulously fine-tune and repair it manually to ensure absolute uniformity in thickness and electromagnetic properties. What happens if this intricate system fails? In terms of propulsion, the B-2 Spirit is equipped with 4 General Electric F-118-GE-100 turbofan engines without afterburners. This is a special design choice that helps to minimize infrared emissions and heat signatures, making it much harder for the enemy to detect. The total thrust of these four engines is approximately 77 kilonewtons each, allowing the B-2 to fly at a cruise speed of about 900 kilometers per hour, roughly subsonic speed. While it might not be the fastest aircraft in the sky, its unparalleled silence and stealth capabilities are the B-2's truly formidable weapons. The B-2's flight range is an astounding 11,000 kilometers without aerial refueling. This is enough for it to take off from a US base and fly directly to a target deep in Asia or Europe and return without needing to land midway. When refueled in the air, this number can even double, transforming the B-2 into a true global strike machine. Its maximum flight ceiling is over 15,000 meters, helping it fly higher than many current tactical air defense missiles. The empty weight of the B-2 Spirit is 71.7 tons, meaning that the body and its systems alone are almost equal to the maximum takeoff weight of many heavy fighters, like the Su-57 or F-15, when fully loaded. The B-2's maximum takeoff weight of 170.6 tons allows it to carry a huge bomb load without compromising its stealth capability. What kind of destructive power can this flying destroyer unleash? The B-2's immense payload capacity allows it to carry up to 18 tons of bombs in its two internal weapon bays, maintaining its stealth. This makes the B-2 a true flying destroyer. Its two internal weapon bays can hold a variety of devastating armaments, including up to 16 AGM-129 ACM nuclear cruise missiles or 16 B-61/B-83 nuclear bombs. For conventional missions, it can carry 80 JDAM Joint Direct Attack munition, 500-pound guided bombs or 16 GBU-31 2,000-pound bombs to destroy hardened targets and special fortified infrastructure. Crucially, the B-2 is the only aircraft currently capable of carrying the massive GBU-57 MOP, Massive Ordnance Penetrator, a penetrating bomb weighing up to 13.6 tons. This weapon can burrow dozens of meters into the ground to destroy critical enemy underground facilities, such as bunkers and command centers. In terms of electronic systems, the B-2 possesses a sophisticated active electronically scanned array, AESA radar, and modern electronic warfare systems. These advanced electronics enable it to jam enemy radars and utilize multi-directional sensor networks to detect threats from afar, providing early warning. Overall, these parameters create a strategic machine that is almost invisible in the sky, something incredibly difficult for an enemy to detect, challenging to shoot down, and even harder to stop before it completes its mission of attacking and destroying deep within hostile territory. Thanks to the combined strength of its long-range, high-payload, stealth design and the ability to carry a variety of weapons, the B-2 Spirit remains the primary strategic asset of the US military. The combination of superior technology, optimal aerodynamic design, and weapon power makes it the main tool in all US deep strike combat plans, preemptive strikes, and nuclear deterrent strategies. If there is a symbol that fully represents the modern American philosophy of war, it is the design of the B-2 Spirit. What surprises many people most when looking at the B-2 Spirit is the complete absence of tail wings, a part that all modern aircraft consider an indispensable factor for maintaining balance and adjusting flight direction. So how can the B-2 still quietly glide through the sky, stable and steady like an invisible ghost, without any tail wing to control it? The secret lies in two key elements: the aerodynamic design of the flying wing and the extremely advanced fly-by-wire electronic control system. With its flying wing form, the entire body of the B-2 is designed to both create lift and maintain aerodynamic balance. The curvature and tilt angle of the wings are calculated with extreme precision to help distribute the airflow evenly along the wingspan of up to 52 meters, thereby minimizing the phenomenon of vortices or eccentric drag, factors that can cause an aircraft to become unstable when there is no tail wing. The huge wingspan of the B-2 is not accidental. Each curved angle and every contour of the wing edge are meticulously designed so that the airflow slides evenly across the surface, creating strong lift without causing the instability-inducing vortices. The leading edge of the wing is slightly curved downwards, helping to break up vortices from the outset. while the trailing edge is equipped with small flaps called elevons. These elevons completely replace both the pitch, horizontal flaps, yaw, vertical rudder, and roll, horizontal flaps, controls of traditional aircraft. When the pilot wants to climb, both elevons lower to increase lift. When wanting to turn left, the left elevon lowers, while the right elevon raises to create torque around the longitudinal axis. All these movements are controlled by the fly-by-wire electronic system because only computers can process fast enough to keep the B-2 flying stably in the sky. The B-2 is inherently very difficult to fly. Even a slight whirlwind or a shift in cabin load can cause the plane to tilt. Therefore, all flight stability activities are assigned to this extremely modern fly-by-wire system. Sensors and computers continuously measure speed, angle of attack, wind force, and tilt, then instantly adjust the elevons so that the plane always maintains a stable state without the pilot needing to intervene manually. This system processes hundreds of calculations per second, far exceeding human responsibility, helping the B-2 maintain perfect balance even without tail wings. Hundreds of calculations are performed to determine how much the elevons need to tilt to compensate for these changes, ensuring the B-2 always flies straight and smoothly without the pilot struggling to adjust. In fact, a normal human operator cannot fly the B-2 without the assistance of this system. The aircraft would immediately fall into an uncontrolled state because the absence of a tail makes it extremely sensitive to all air turbulence. Thanks to the combination of the monolithic wing shape, which reduces the radar reflection area, and this superior electronic control unit, the B-2 becomes the ideal stealth machine that can fly tens of thousands of kilometers through the enemy's air defense net while still maintaining absolute stability. It's a true testament to the fact that when the art of aerodynamics and electronic engineering converge, the seemingly impossible thing like flying without a tail becomes a reality. Although the B-2 Spirit is lauded as the ultimate symbol of US air power, this machine is not completely invincible and also carries some fatal weaknesses. The first is its enormous operating cost. A B-2 costs more than $2 billion to manufacture, making it more expensive than any military aircraft in history. The maintenance of the stealth coating alone after each flight requires hundreds of hours of labor and specialized equipment, which drives the operating cost per hour to nearly $150,000, a figure that is a constant headache for the Pentagon. Furthermore, the stealth design of the monocoque flying wing, while effectively reducing radar reflections, makes the B-2 susceptible to instability if there's a problem. Without a tail to self-balance like a conventional aircraft, the B-2 is entirely dependent on its fly-by-wire system to maintain stability in the air. If the software or sensors fail, the aircraft can quickly fall into an uncontrolled state. This devastating vulnerability was tragically demonstrated on May 23, 2008, at Andersen Air Force Base in Guam, when a B-2 with registration number AV-12 crashed shortly after takeoff. The cause was later determined to be high humidity, causing two outdoor atmospheric pressure sensors to fail, transmitting incorrect data to the flight computer. The flight control system, relying on this flawed data, adjusted the elevons in the wrong direction, causing the aircraft to nosedive into the ground and explode just seconds after leaving the runway. This was the most significant B-2 loss in history, but it was severe enough to cause the entire remaining squadron to temporarily halt flying for a thorough inspection. In addition to this incident, the B-2 is also limited when operating in adverse weather conditions. Its radar-absorbing paint is very sensitive to humidity and temperature, requiring the aircraft to be stored in special climate-controlled hangars when not in use. All of this makes the B-2, while a symbol of power, also a testament to the paradox of modern warfare. To create an invincible weapon, humans must accept its inherent fragility in the face of the smallest technical errors. Does the unparalleled strategic advantage outweigh these significant drawbacks? The B-2 Spirit is not merely a stealth bomber, it embodies the boldness of technology far beyond its time and the strategic ambition of the US Air Force in the new era. For more than 3 decades of its presence, the B-2 has silently flown through the harshest skies, delivering wordless deterrent messages to all potential opponents. Its existence alone reshapes geopolitical calculations. It represents a capability that forces adversaries to reconsider their actions, knowing that no border or defense system is truly impenetrable. This aircraft, a product of immense human ingenuity and determination, continuously pushes the boundaries of what is possible in military aviation. The B-2 stands as a testament to an ongoing philosophical debate. Can ultimate power truly guarantee peace, or does it merely perpetuate a dangerous standoff? It prompts nations to invest heavily in both offensive and defensive technologies, creating an unending cycle of innovation and counter-innovation. The Ghost of the Sky remains a potent symbol, not just of American military might, but of the relentless pursuit of technological dominance in an ever-evolving global landscape. It reminds us that even the most cutting-edge advancements come with their own complexities and vulnerabilities. The story of the B-2 Spirit is a chapter in the larger narrative of human conflict and the quest for security, a narrative that continues to unfold with each new technological leap. What will be the next chapter in this relentless pursuit of strategic advantage?